go ahead, find data file vintage. So it has the monthly sales of wine for the past 3 years. We're going to go ahead and predict using those past historical information. We're going to make predictions for the next 12 months for the next year. How? By using 5 different techniques. So we're going to come up with 5 set of forecasts: exponential smoothing, 3 months moving average, seasonal forecasting, trend forecasting, seasonal and trend forecasting together. All right, so that's going to hopefully give you a quick review of chapter 8. Other than these for the exam, so you need to know how to perform each one of these. And also you need to also be able to compare them. If time allows, we may compare like 2 of them. You just need to find the error, right? Error for each one of them. And then whichever that gives you less error is expected to do better also in the future. So that's the idea here. You can find the error, let's say MSE, mean squared error, and then calculate MSE for each one of them. Whichever that gives you least amount of MSE is going to be, we can trust that better than other ones, right? So we can pick whatever forecast that method with the least squared error gives us. All right, I'm going to go ahead and copy this question real quick, and then we go ahead and download the Excel file and answer the question. All right. So this question, copy. So I'm just going to close this. We go back to chapter 8, download the data file. So you need to go back to the general section. And chapter 8 is the time series and forecasting. Raw data files. Open it. Okay. Data file, vintage. So the third module, after we do the second module, after we complete the second exam, the third part, the third module is really important for you guys to watch the videos, attend classes, because usually that's the one that is newer compared to other stuff that we do in this class. And usually students have compared to other parts, those are actually perceived to be more difficult. So I thought that since we have a few seconds, I just mentioned that. All right, so here we have the question. 5 different methods. We're going to use them to make predictions. So I'm going to go ahead and just maybe mention before we actually get to that, let me just mention something beforehand. So the data, here, I mean, the type of data set that we have is called a time series. Why do we call this a time series? Jacob.
Does it have to do with the fact that it's like months? So it's over kind of time period?
Exactly. So we have we have these values, but we also have the timestamp, right? We know exactly when they happen. So they're actually coming with a date or time. So that's really why we call it a time series, right? They apply to the same person, to the same company, but in different time periods. That's why we call this a time series. So these techniques that you see here, these are the ones that we use for time series. The first two are actually called averaging techniques, and they're used when you have random. The data file, like the data series, is pretty much flat, like there you see actually horizontal pattern, but there are some random fluctuations. When that's the case, these techniques are the best. So when you have horizontal pattern, horizontal. I probably have to type, yeah. It's better if I type horizontal, right? This one, the seasonal, go ahead, sorry.
Could you go over what horizontal means again?
Yes, absolutely. Let me just, yeah, so just remember this. These two are for horizontal. The second, the seasonal is for seasonal. Trend is when you have trend. Seasonal and trend is when you have both of them. And let me just explain what I mean by horizontal and other ones. So let me get rid of these. All right. Okay, so let me just do this. Maybe horizontal is if this is it, if this is your time, and this is your variable, whatever your variable is, X or Y. Horizontal is when you have your data points are like that. As you go from left to right, your data points are like that. Right? When you draw the trend line, you see that there is no trend. And then you see the numbers fluctuating randomly. You can't find any specific pattern with regards to the fluctuations, with regard to the point. So it's completely randomly fluctuating around a constant mean, around a horizontal line, around a flat line. So that's when we call it a horizontal pattern. And that's usually happens for the products that are at their maturity stage, right? So the product is pretty mature, like consumption of gasoline, for example. That's actually an essential product, like consumption of foods, vegetables, right? Potato, for example, it's pretty horizontal from a week to another week. It's pretty stable, the consumption. But there might be fluctuations depending on, weather, depending on a lot of other stuff, but the variation are usually small and it's random. So that's horizontal. The second one, the second is trend. Let me just mention trend. Trend is when you have gradual increase or gradual decrease in the data. So let's say data points are like that. There are still fluctuations. You see the randomness here, but they're fluctuating now around a straight line or a straight curve. Doesn't have to be linear. It might be a curvilinear chart. So, and it can be increasing trend or decreasing trend. There might be, like your points might be like this, right? So, but as long as you see a gradual shift in the data, right? That's called a trend. That is called trend pattern. Okay, next one is seasonal. Let me just draw something right here. So seasonal is when you have, let's say you have multiple cycles, like if you're considering a restaurant from today, like the hourly sales, for example, from a day to another day, from a cycle to another cycle, you see the same pattern repeating, This is when we call it a seasonal. I mean, you see here that seasons are, like in this case, are hours or shift. And then a cycle is a full day, like one day to another day to another day. But technically, usually we have cycles. I mean, when we're considering sales of seasonal product, we usually are looking at a year as a cycle, and then we see the same pattern repeating from one year to another year. So you see like sales of ice cream, for example, dropping during fall and winter time, and then backing up, ramping up again in spring, and actually peaking during summertime, right? And then this pattern repeats itself from a year to another year. That's what we call seasonal. And then you may also have a seasonal and trend, or let's say seasonal and increasing trend. I would just go with that. So let's say like this is 1 year, second year, third year. Let's say iPhones, for example, at certain times during a year, like there might be additional, say, I mean, this might not be exactly good representative of that, but at certain year, you may have like there are some seasonality in a year, right? At some certain months of the year, you see a peak in the amount of sales of iPhones. But overall, from a year to year, and then you see the same pattern repeating from a year to another year. But overall, when you look at a year to the next year, to the next year, and so on, you see an increase in the sales overall. But you still see, when you're looking at a one season, one cycle, you see that there are seasonal fluctuations. But when you look at the overall data, you see that there is also a trend. The data that we have here actually is going to be this one, seasonal plus trend. I think this would be the best representative of this data file that we have, seasonal plus trend. And we can actually verify that really quick. So let me get rid of this. Hopefully I answered your question, Sam. And these are pretty much all the patterns that we are working with in this course.
Yeah.
Yeah. All right, so let's go ahead and do these. So exponential smoothing, alpha 25%. So exponential smoothing, the formula is F exponential smoothing alpha. The formula is as follows. F forecast at t+1 is equal to alpha times A, or actual value, at time t plus 1 minus alpha times f of t. Forecast at one period before, right? So that's called exponential smoothing. As you can see, for forecasting at each period, you need to know the forecast at the previous period. So let's say when you're at period 10, if you want to make a forecast here, you need to know the forecast in the previous period, and so on. And if you go backward, eventually you reach to period 1, and then you need to know the forecast for period 0. So there has to be a starting point. Usually the starting point is like this: F1 equals A1, or F forecast at period 1 equals actual value at period 1. Or there might be a specific, let's say F5 equals to 12, for example. If that's the case, you just come here, put 12 here, right? But if there's nothing, you just go with this one. F1 equals to A1. Forecast at period 1 equals to the actual sale at period 1. Starting from the next period, and I'm just going to go ahead and type 0.25. 0.25 times alpha times actual value in the previous period plus 1 minus alpha times previous forecast. And then you can just drag this formula down all the way to the end of your data set. Now, I said the objective here is to make forecasts for the next 12 months. So the next 12 months, 37, 38, all the way to 48, right? Yeah. We don't have the actual data. Of course, we don't have the actual data for the next 12 months, but we want to have something here. Exponential smoothing, like I said, it's an averaging techniques. You always need one period forecast for one period before. So for period 37, you can actually drag the formula down for period 37. But after that, you won't be able to drag it down because you don't have the actual sale. If you do that, your data is going to go actually converge to 0 because it's getting smaller and smaller. You don't have the forecast, it's always put 0 instead of that, right? So you don't want to do that. It's actually work for horizontal. Usually when this happens, you are going to repeat the same forecast for any future observation. For any future period, you're going to use the ones that, to the best of your ability, you forecasted, which was actually period 37. Any question? So we just came up with the forecast of period 37, and we use the same thing. Same thing applies to the 3-month moving average. The next one. All right, exponential smoothing. Next one is going to be 3 months or moving average. K equal 3. So for moving average at each period, Lavina, yes. Yeah. I just dragged the formula from period 36 to 37. So for moving average, and then K is the parameter, forecast at each period, forecast at period T, for example, or T, I just put T, is equal to average of past K values, actual values, right? So you just need to take the sum of past K, you just need to add them together and then divided by K, sum divided by K. So sum of A T minus 1 plus A T minus 2 plus A T minus K, parenthesis closed, divided by K. Simply taking the average, sum divided by the number of observations. sum divided by K. And that's what we're gonna do. K is equal to 3 in this case. That's just a specific number. 3 months moving average. K equals 3, the number of data points that we're gonna consider. So for each period, in order to be able to predict, you need to know the past 3 observations. So I won't be able to calculate the forecast. I won't be able to forecast for period 1 to 3 because I don't have their past 3 history. I'm just gonna start from week 4, and it's gonna be average, simple average of past three sales, guys. Don't make sure not to make this mistake, right? Just go ahead and select the actual sales, average of past 3 observations. And then just drag it down all the way to the end of period 36. That's how it works. For period 37, you're gonna go ahead and drag it down. And as you can check here, it takes the average of sales in period 34, 35, and 36. So that's perfect. But after that, again, if you drag it down, it's gonna, since you don't have actual data, it's gonna replace, it's gonna put 0, and eventually you get 0. Or yeah, so you won't be able to take, it's actually average of zeros, it's gonna be zeros, but since I, yeah, what's wrong? Yeah, oh, average of blanks, yes, so that's even, Nicholas, yeah, at weeks, it's, let me just fix this one. And then, yeah, I go back here. I started at week 4. I won't be able to do it for week 1 to 3 because I don't have anything. I don't have their past 3 like history of like record of sales. So I have to start from week 4, and then I just complete doing it for all the periods. And for period 37, I'm able to do it with no problem. I won't be able to drag it down because, like I said, if you drag it down one period, you see, you don't, I mean, it's just taking this and dividing it by 3. So it's just underestimating, right? Under forecasting. So you don't want to do that. Sure. And you basically want to follow exactly the same thing like we did for previous one. Which is going to be copying exactly the same numbers. Let me just take this. All right, okay. Copying the same number that you found for period 37 for other periods. That's how we go with methods that are good for horizontal pattern. Horizontal pattern, the assumption is you find the average, you stick to the average. That's the best bet, right? That's the best thing you can do. Go with the average. And that's what we're doing here. So that was the moving average. Let's just move on to the next one. Seasonal, trend, seasonal, and trend. All right, I want to do trend first, and then we go and do seasonal and trend later, right? So let me just add a few columns here. We're gonna do trend first, and then we're gonna go ahead and add seasonal as well. So for trend forecast, the only thing you need to know is the trend line equation. You just need to have the linear equation that explains the relationship between sales and the time stamps, right? So you just want to understand this relationship. Once you get that equation, you can go ahead and use that equation to make predictions for the other period. So let me go ahead and find that equation. How do we find it? We just draw a trend line, add equation. So trend, find equation from trend line. Time series plot. Just for your information. So the trend, we're gonna find the equation from the trend line at the time series plot, and we're gonna just apply the formula. So for that, you just need to have a time series plot. Insert a line chart. Line chart. Line chart, and then let me just add this stuff. So this is sales. This is period. So that's the line chart. Time series plot. All right. You just need to add the trend line and add the equation on top of it, and just get the equation and use the equation. That's all we need to do it. That's all we need to do, right? So just go ahead, add trend line. And for your trend line, go ahead and it's pretty horizontal. I don't know if we get any equation actually.
What data is the trend line, is the line chart for?
It's sales, actual sales.
Okay.
Yeah, I just use sales, and you do it for 36 period, from 1 to 36. And then add equation on top. So y hat, I just put hat. That way we know that this is a forecasted value. Forecasted value, this line, is equal to, and instead of x, I put period number, 187.86 plus, actually minus the coefficient for period, right? Times the period number. So we're gonna use this one, this equation, to make predictions. Control C, and I'm just gonna move this toward the right side here. All we needed was the equation. I go back here. And then I'm gonna start from, honestly, I don't need to do it for period 1 to 36. I can just move on to period 37 because we already have their period number. So we can directly go ahead and do the forecast, but that's okay. I can do it for all periods. So I'm just gonna go ahead and apply the formula. Instead of period, I'm just gonna multiply it by the period number, month. So the slope times actual sales in period 1 plus, the period number plus the intercept. Slope times the period number plus the intercept. That's going to give you the trend forecast. And you can simply drag this down all the way to 48. Because as you can see here, you just need to have the period numbers. 44 times stop. Any question? So this is a trend forecast. Now you have forecast for the next 12 months. All right, for seasonal and trend. So what you need to do, you need to find the equation. That's how we do it. There are different ways that you can do seasonal forecasting, but in this class, we're going to use the equation. All right, and we're going to first create the dummy variables, and then we're going to create the dummy variables, and then find the equation, and then use the equation. Apply the equation to get the seasonal forecast. So I'm just going to insert a few more. So I'm first, before going ahead and doing the forecast, I just need to create the seasons, actually, the dummy variables that capture the season. How many seasons do you think we have in this example? In this example, specific example. Let's take a look at, again, at our time series plot. So each year, let me just draw this, each year. So first year, 11, 12, 12 is right here. So this is 1 year. And then second year is right here. Second year, and then third year. So 1 year, 1 year, 2 year, 3 years. How many, so like I said, you see similar pattern repeating from a cycle to another cycle. So each year here is one cycle. One cycle, one cycle, one cycle. Right? And then how many seasons do we have in this case?
4.
I mean, each year has 4 seasons, of course, but these are like weather seasons. In this example that we're doing, so season is each subset of your cycle that you want to actually use it as a reference point, right? So in this case, we have the monthly sales. If you want to use spring, fall, summer, and winter, you have to now convert the data into quarterly sales, which is going to be too much work, right? You just need to add them together and completely change the structure of your data. And then eventually when you come up with quarterly forecast, you need to, again, break them down and make them into monthly forecast. So it's just a lot of work. Instead of that, why not consider 12 seasons? Each month is going to be season. Like you remember in the example that I gave you, I said for a restaurant, for McDonald's, for example, each day is a cycle, and then shifts are seasons. For seasonal forecasting, shifts are subsets of a day that we use for measurement purposes. Shift 1, shift 2, shift 3, or hour 1, hour 2, hour 3, all the way to hour 12, for example, from this day to the next day. So seasons are different. The meaning of seasons in what we're doing in seasonal forecasting versus the typical conventional meaning of seasons that you guys know from your day-to-day life, right? So let me just go ahead and create the dummy variables. And you already know how to create the dummy variables. So since we have 12 seasons, we're gonna go ahead and create how many dummy variables? Always, I mean, when you're doing dummy variables, when you're using dummy variables, indicator variables, you're always going with n-1.
So 11.
11, you got it. So month 1 all the way to month 11. And the reason is because if it's not month 1, if it's not month 8, if it's not month 2, 3, 4, 5, 6, 7, all the way to 11, then it's month 12. It can't be anything else. That's why we don't need to do anything for month 12. It's already being captured by not being any of the other 11. It has to be month 12. Otherwise, if you do that, it's going to lead to a case of multicollinearity. Perfect correlation, actually, which is bad. We don't want to have that. So month 1 to month 11. And now the definition of month are going to be, these are dummy variables. If turns out to be longer than I expected, but I'm just going to go ahead and do this. You know what? I'll manually do it rather than putting the formulas, because we need to have month numbers also. I'm just going to go ahead. Yeah, I can put it manually, or I can just put like month number, because for this one, this is actually the period number. It's not month of the year, right? You can't have month 17 in a year. So you just need to add another one, which is now the month, and just have 1 to 12. And this 1 to 12 repeats from a year to another year. So now this captures the month in a year. Does that make sense? So I'm just putting the month number here. We didn't have that. I mean, we had it for the first year, but after that, it was just recording the period number, not the month number. Now I can go ahead and put the dummy variables here. Month 1, if month number is 1, put 1, otherwise put 0. By the way, I'm going to add, since I need them to be next to each other, I won't be able to insert columns in between, and I won't be able to show you the formulas then. So just to show you the first formula that I use, formula text, this one. You know what? I'm gonna also fix the B, the letter here, the name of the column, because I know my stays are always in column B. So that's okay. And now I can drag it to the right, but I still need to update those. So 1, 2. I could have, instead of 1 and 2 and 3, I could have recorded them in separate cells and just refer to those, but that's okay. This is not taking too much time. Seven, 8, 9, 10, and 11. And we just did it for month 1 to 11. We're checking, this is row 1. If the month number at period 1, the first period, is 1, put 1 here, otherwise put 0. If it's 2, put 1 here, otherwise 0. If it's 3, put 1 here, otherwise 0. If it's 11, put 1 here, otherwise 0. And if we just drag the formula down, if you get this formula correctly, you can just drag it down. Oops. You can just drag it down, and it's going to capture all these dummies for you.
Professor,
That turned out to be a little long. Yes, Jake.
could you just show me what's B3?
B3 is the month number. I inserted this.
Okay.
Yeah.
Okay, got you.
Yeah, guys, just be careful about this one. Month is something that I just added, and it's just month number because we didn't have this one. What we had before was period number, not the month number. For creating the dummy variables, you need to know the exact month stamp of each period, right? Highlight it. So now we have 11 dummy variables. You want to give it a close look. Make sure that you have 1, 1, 1, 1, 1 on diagonal here. 1, 1, and then 1 row 0, and then it starts over again from here. Yeah, 1, 1, 1, 1, 1, all the way to here. And yeah, 0, 0, 0, 0, and then again 1 start. Wait, yeah, yes, 0, 0, 0, 0 here, and then 1 starting from here, and then going all the way to 0, 0, 0, 0 again, which indicates the December, month of December, where all the 11 dummies are 0.
How did you get the month 2?
Say it again, month 2, where, like
So
where?
I got the month 1 like for the first row like, right there. But how do you get the month 2 and month 3?
You mean the formula? I'm
Yeah.
not sure if I.
Yeah, the formula.
So it's right here. So I'm just putting the formula. So this one, it says if the month number is equal to 2, type 1, otherwise type 0. And whenever the month number is 2, it puts 1. It returns 1, otherwise 0. So like this one, let's just take a look. Here, the month number is 2. This is period 14, February of the next year, right? Or previous year, depending on which direction you're looking at your data. So here, that's how it works. And then you just repeat this thing. If the month number for the first period is 3, put 1, otherwise put 0. If the period number, same thing, B3, period, month number. If the month number for period 1 is equal to 11, put 1, otherwise put 0. Okay, so we have the dummy variables. Once you have the dummy variables, the rest is just running the regression, getting the equation, and applying the equation, which I would assume is going to take too much time. Just gonna run the regression, get the equation, and then just do it for seasonal. And I'm just gonna leave the seasonal and trend for you guys as something you guys are gonna complete. Yeah, sure. Okay, so I'm just gonna go ahead and run the seasonal. So we need the seasonal equation, seasonal forecasting equation first. And then when we have the equation, the rest is pretty easy. We just need to apply the formula. I'm inserting a few columns just so we have enough space here. All right, for seasonal, what you are gonna do, you're gonna run regression. Okay, so what is it that you wanna predict? Say, from period 1 to 36. Period 1 to 36, C2 to C8, 38. What is your X range? What is it that you want to use for prediction purposes? It's going to be the dummy variables. Jacob, go ahead.
Sorry, I was gonna say the dummy variable.
Yeah, thank you. The dummy variables. Month 1 all the way to month 11. all the way to the, not to the end of the table. You want to make sure that you're only going all the way to the end of the third year or period 36. In this case, V38 is going to be the end of, I mean, you have to have the same dimensions here. For Y and X range, you have to have same number of rows. So you're using this information, past 3 years, 36 data points, to train your model, to come up with a seasonal model, and then you can use it for prediction purposes to predict the next 12 data points. That's why I excluded V39 to V50. I just updated it. This was actually 50. So check labels, output range, just put it in the same sheet. Put it right here. No need for residual plots, no need for nothing. We don't worry about the significance right now. We just want to get the estimated coefficient.
The L to V, that is just, is that the, what is that?
Dummy variables, Carson. Yeah. Month 1 to month 11. And yes, C was the actual sale. I just inserted a month in between A and B. So now C is my previous B, which is the sales, actual sales. All right. No, like I said, no need for nothing. Let's just get the equation quickly and use the formula. So this is the equation. I'm not gonna even write down the equation as long as we understand the equation. So this is it. So now our seasonal model is going to be this linear equation that tells sales or predicted sale is equal to intercept 224 plus the coefficient for month 1 times month 1 plus 19 times month 2 plus 24 times month 3 minus 31 times month 4, so on and so forth. What is Y and X, Aryan? Y is the one that you want to predict. Y is sales. X is the dummy variables, the seasons, right? So I said we have 12 seasons in this example, 12 months. We used 11 dummy variables to capture these 12 seasons. And we use these 11 dummy variables as our X range. We use sales, which is what we want to predict, as our Y range. Let me go back and show you real quick. Here. C, column C, look. Sales is my column C. Okay. L to V is month 1 all the way to month 11. So, and then just make sure to include 3 years worth of data. You're not looking at the 4th year, right? Because we don't have the actual sale for that. That's it. And then record the model. Once you have the model, you can just use the formula to come up with seasonal forecast. So these are the coefficients, and we're going to use these coefficients to come up with seasonal forecast. What you're going to do for each period, you're going to plug the month, the dummy variables, the value of the dummy variables. You're going to plug these values into the equation here and get the get the forecasted value or estimated value. What I'm going to do, I've already in the videos, when you watch, there is a function in Excel, sum product function, that applies the linear function here. When you have an array that contains coefficient and another array that contains the variables, you can actually use the sum product, summation product, right? You can use that function and give these two arrays what some product is going to do is going to take the first array of first cell of first array, multiply it by the first cell of second array, plus second cell of the first array multiplied by the second cell of the second array, plus, and so on and so forth, right? So it just multiplies the corresponding cells, adds them together. That's all that happens. But you need to have these in the same dimension. Here, for the first period, I have the month in row, 11 months in one row, but my coefficients, so the first coefficient here that corresponds to month 1 is right here. The second one, instead of being here, is in the next row. That's not good. I don't have them in the same dimension. So what I'm going to do, I'm going to copy this, Control C. I'm going to transpose this. Transpose, right click, transpose, paste, transpose. So that way I have the same coefficients, but in a row. You see why I'm doing this? Because I'm going to use the sum product function. Sum product function, you need to have coefficients and variables, values in the same form, in the same dimension, in arrays with the same dimension. That's what I'm doing. So now, seasonal forecast, sum product of coefficients. Let's just do intercept first, because intercept is also important. And I'm going to fix this value. So make sure to add the dollar signs for intercept plus sum product of coefficients for month 1 to month 11, F4, comma, the value of the dummy variables for from month 1 to month 11. Enter. Enter. And then you can simply drag it down. Yeah. From where you want me to start over? So I would assume you guys got how to do the dummy variables. Just a question, sure. Do you guys know how to get the dummy variables? We had 12 seasons, 12 months. I assume each month is going to be considered as a separate season. So 12 months, 11 dummy variables. This is how we capture the dummy variables. You're going to look at the month number. If it's equal to the index, right? Index corresponding to each one of these indicators, to each one of these dummy variables, you're going to type 1, like this one, which applies to month 1 of the year, 11 of the year. If it's not month 11, for example, for this one, you type 0. So when you get the dummy variables, what you need to do, you need to run a regression analysis in order to find the equation that explains sales. So sales based on these dummy variables, 11 dummy variables, month 1 to month 11. When you run the regression, Excel is going to give you the numbers in the coefficients actually in one column, right? That's okay. That's absolutely okay. So you have the coefficients and you have the values for the first period. Let's just do for the first period, and then once you have the formula, you can drag the formula down. So you have the values of these dummy variables and you have their coefficients right here. So you already know how the linear equation works. So you have the intercept and then you have the coefficients. You simply need to multiply the coefficients by the value of the dummy variable and then add these together. That's how you plug the values into a linear equation, right? You already have the coefficient. I just skipped the writing the equation part, because I'm sure you already know. So instead of doing this, what you could do, let's say for this one, you could just do this: intercept plus coefficient for month 1 times the value of month 1 for the first period, plus coefficient for month 2 times the value of month 2, plus the coefficient for month 3 times the value of month 3. So you could simply do this. Instead of just typing this over and over 11 times, I decided to use the sum product function, because sum product function does exactly the same thing. Gets 2 arrays, multiply corresponding cells, right, one by one, and then adds these together, which is exactly what linear equation does. So in linear equation, you have a coefficient array and you have a variable array, xi's and bi's. So you just need to multiply bi by xi and then add them together. B1 times x1 plus b2 times x2 plus b3 times x3. That's just the definition of, let me go back here, show you the linear function. Yeah, here. This one. This is just the definition of linear equation. So you have b1 times x1 plus b2 times x2 plus bq times xq. Now, in Excel, you have, these are bi's, coefficients, or bi's. So you have bi's, and here you have xi's. This is xi's. Those are bi's. So instead of typing manually one by one, you can use the sum product function. So sum product function gets 2 arrays of the same size, multiplies corresponding cells, adds them together, which is the linear form. So instead of having this in column, I just copied this, Control C, came here, click here, paste, right click here, sorry, right click, paste special, transpose, and it just same values, but just transpose. Instead of one column, you have them in one row. Now that we have them in one row in the same format as my variables, I can go ahead and, just use the formula, intercept plus sum product of the variables for the first period, 11 dummy variables, and 11 coefficients. And I've fixed the coefficients because I'm gonna drag, if I wanna drag the formula down, if I wanna copy the formula, I wanna make sure that coefficients are fixed. They're not changing from a cell to another cell, right? Let's take a look at period, I think 12 for the first year. See, intercept plus sum product of the coefficients and the value of the dummy variables, and so on and so forth. So any question? And since there's still another part to this question that you need to solve, and since there's another part, I'm gonna extend this one until Friday night. All right, but try to complete it right now, like after the class, if you can, if you have time. Try to complete the seasonal and trend forecasting. We already covered the seasonal trend, 3 months moving average, and exponential estimate. You just need to do the last part and submit it. But anyways, I'm gonna give you until Friday night to complete it and submit it. All right, can you guys please do me a favor and put yes in the chat box? Yes, thank you so much. That way I have, yeah, I know exactly who presented. Thank you. I'm gonna stop recording now.